All right, Cody Breeze with Devitt Machinery. Going to be going through an application that we've done on site for a customer that had a very unique problem. One of our customers has a big, large shear that had a coupling alignment issue. And here you can see where the coupling was sagging towards the back and the swisher plates were coming into contact with the top of the coupling. After the customer removed the drive shaft and the coupling, we were able to inspect it further and check out there was massive wear on the flats and on the rounds. The customer went through an objective to machine it with another company, and the repair was to set up an on-site machining system to cut the rounds and then a milling machine to cut the flats true. Then they were going to weld up the flats and the rounds and remachine everything after everything was welded to fit the coupling to proper size. They were going to do the same thing to the coupling itself. Devitt Machinery and Fast was on site, and what happened was we were there for a different project, and the customer just had a off feeling to bring us in just to go over a couple things. And what we suggested is, instead of doing all that extra work, we have an alternative with our product called DWH 310 Flex. And what we were suggesting to do was inject the coupling to the shaft itself, to the crankshaft, to mold to fit the actual profile and to fill what was missing in the void. After examining with our laser tracker, we indicated in the flat and the rounds and recorded excessive wear to the point where we were to 1/4 of an inch to 3/8 of an inch with wear. The actual top was around 260. The bottom was around 273. And the round was out of round almost close to 3/8 of an inch. And when we were doing the actual pin itself, those numbers also reflected onto the pin surfaces. So the idea was to then take the coupling and align it to the pin. If I can go in here and check this out. So we actually put the coupling and the drive shaft backed up, and we actually put the coupling into alignment to the crankshaft pin. And when we did that, we were able to use the laser tracker to actually align it concentric with the crankshaft inside the shear. We took the coupling to the machine shop, and we actually machined in injection ports that we were able to fill the coupling with the DWH 310FL. The bottom took about 8,000 grams to inject, the sides about 2,000, and the top about 4,000 grams. And then it's estimated that 44% is original metal, and 56% is actually filled with the DWH, creating the molded to fit contact that they needed. And there's the before and afters, where the before you can seriously see the misalignment, and the after it's back into alignment, where we were able to level and straighten the coupling back. Now, the alternative that they wanted to do, the customer was thinking this was a Band-Aid fix, and this application happened back in 2016. The customer then went to into design mode, reverse engineering mode, sourcing to see if they can get somebody to make the coupling and the crankshaft itself. And it turns out it took the customer over 2 years to complete getting these parts remanufactured. And after several visits with the vendor that they were using, found out that stuff was made wrong, and they had to overcome different hurdles, and they had to actually revisit some other metallurgy. They had to remake a whole new crankshaft, and delays kept on happening. And meanwhile, this fix was running in the background that we did. So it took the customer almost about 2.5 years for those parts to hit their shop floor. Then the next battle was actually figuring out how to install the components, because no one's ever had the machine apart. They didn't have the lifting capacity over the top of the machine to take everything apart to actually physically transfer the crankshafts, and they didn't have an expected timeline for it or an engineered work process to actually do that. So while all that is still going on, the machine is still running because we did what we injected everything prior the other customer coming in and doing the on-site machining. So with layering this in with, you know, all these problems, trying to source the proper fix and getting, new parts made, that proposed its own challenges in itself, because they didn't have any means or anything to go about it. So after they executed it from start to finish, then they realized, it's much cheaper and cost effective for them and time savings just to take all the old DWH out and re-inject it again, to save them the time of pulling everything apart, the line being down, and not really having a comfortability of, can we hit that target of the line being down? Can we get back up and running again? So the DWH served a great application here in injecting into this coupling that sees tremendous amounts of torque, a lot of forces in turning, a lot of just, everyday grinding and pounding of this unit, and it still works and is operational today. And if it was ever to let loose, we can remove all the other excess material and re-pour new DWH 310 in.